we will learn about image histograms, pixel intensity, and the radiometric resolution of a satellite image to better understand the forthcoming tutorials. By the end of this video, we will understand the concept of histograms and be able to plot the histogram of a Landsat image using Google Earth Engine. Look at this satellite image. By zooming in to the maximum on this satellite image, we can observe that pixels are the fundamental building blocks of the image. Each pixel corresponds to a specific area on the Earth's surface. In the case of Landsat 9, a pixel represents an area of 30 meters by 30 meters on the Earth's surface. This is also known as the spatial resolution of the image. Each pixel in the image has certain values encoded. These values are called digital numbers, DN. A digital number is a value recorded by the sensor elements that is proportional to the energy of light or wavelength reaching the sensor. It can be reflected or emitted radiations from the surface of the Earth. In other words, we can say that the digital number recorded by a sensor is proportional to the number of photons falling on that. The greater the number of photons, the brighter the pixel. The lesser the energy reaching the sensor, darker the resultant pixel. Integrating these pixels creates a complete satellite image. Every pixel in the image is associated with a digital number. The range of digital number value recorded by a sensor is restricted by its radiometric resolution. Radiometric resolution refers to the ability of a remote sensing system to measure and distinguish between different levels of brightness or shades. Radiometric resolution is expressed in bits. A 1-bit image provides 2 shades of gray, as 2 raised to the power of 1 is equal to 2 shades. An 8-bit image provides 256 shades of gray, as 2 raised to the power of 8 is equal to 256 shades. In this case, the 0dn value represents black, and 255 represents white, with all other values corresponding to intermediate shades of gray. As of now, we have understood the following points. A satellite image is formed by pixels. Each pixel records the light intensity as dn. The range of dn values depends on the radiometric resolution of the sensor. Keeping in these concepts, we will learn about histogram. A histogram is the graphical representation of the distribution of pixel intensity values within the image. The x-axis of the histogram shows pixel intensity values in the image. The y-axis represents the number of pixels that have a particular intensity value. Consider the example image. The dn values and their corresponding counts are shown in the table here. This frequency distribution of dn can be plotted as a bar chart to form the histogram. Now, let's see how to plot the histogram of a Landsat 9 image. The Landsat 9 image available to you has a radiometric resolution of 16-bit. It was originally captured at 14-bit and later enhanced to 16-bit. Therefore, it has the capacity to capture 65,536 shades of gray. 2 raised to 16 will give you this value. First, we will pan to the area of interest and place a point geometry using the Atom Marker tool. The details of the created geometry will appear in the import section of the code. Declare a variable, say L9Image, for assigning the entire image collection of Landsat 9 raw data. This code snippet is readily available in the Landsat 9 catalog. The next step is to further filter the data by date range, location of interest, and cloud cover. A detailed explanation of these codes is available in the video Google Earth Engine 3 Basics displaying Landsat 9 raw images. The video link is available in the description. This will provide a single image with less than 10% cloud cover, specific to the area of interest within the given date range. We can display the satellite image by map.addLayer command with L9Image as the argument. Running the command will display a dark image on the map. Since the histogram is to be plotted for a single band, we can select band number 5 and assign it to a variable. This can be done by select command. The command line var band5 equals L9Image.select B5 will assign B5 of the selected Landsat 9 image to the variable band5. There are a total of 11 bands in a Landsat 9 image. The image containing these bands is assigned to the variable L9 score image. Any of these bands can be selected using the .select method. In the expression L9 image.select B5, the .select B5 command selects the band labeled B5 and assigns it to a variable. Now the variable band 5 holds the B5. Now the map.add layer can be used to display the band 5. By running the command, band 5 will be displayed above the previous layer. Since Google Earth Engine does not allow handling a large number of pixels for plotting a histogram, we need to specify a smaller area of the image for which the histogram will be displayed. Therefore, we can define a new geometry and use the Draw a Rectangle tool to demarcate a small area for which the histogram will be drawn. A new geometry will appear in the Import section and rename it as Box. Now the histogram can be created using ui.chart.image.histogram method. The argument for this method is the image and the region of interest. Here the image is the band 5 and the region is the box. Print the chart using print command with the histogram variable as the argument. After running the program, a histogram will appear in the console. This histogram represents the pixels within the boundary of the box-type geometry we defined. Here, the histogram has incomplete chart labels. These default chart labels can be customized according to our requirements using the Set Options method. Within the Set Options method, we can define the chart title and horizontal and vertical axis labels according to our requirements. Here, the title, vertical axis label, and horizontal axis label can be entered within the Set option. Finally, run the program to get the customized histogram.